Hi guys, welcome to my YouTube channel. Myself Onkar. I am a 2023 graduate and as of now I work as a full-time software engineer in JP Morgan Chase. On this channel I talk about things in tech, software, clearing coding interviews, DSA, system design and much more. So till now in our design patterns playlist, I have created two videos. One is on singleton design pattern and another is on factory design pattern. Do check that out if you haven't already. In this video, we will be discovering yet another interesting design pattern, which is abstract factory design pattern. So the prerequisite for this is that you must have watched my previous two videos, that is singleton design pattern and factory design pattern. Out of that, factory design pattern is most important. Factory design pattern is the basis of this video. We are moving to abstract factory design pattern from the factory design pattern. Apart from that, the prerequisite is that you must be well known with the concepts in object-oriented programming in any language, C++, Java, Python. So let's get started. Okay, so now let's understand abstract factory design pattern via PPT. But before that, let's do a quick recap of factory design pattern. As I said, factory design pattern is the base on which we are making abstract factory design pattern. So, factory design pattern. So this is the pictorial representation of factory design pattern, which we discovered into the last video. So what happens here is that the client, rather than directly talking to the object creation process, it talks to the factory. The client demands an object to the factory. Factory makes sure that the object creation process creates the object, passes it to the factory, and then factory passes that object to the client. What problem we are solving via this? Now here the client and the object creation process are loosely coupled. Any changes in the object creation process, we don't need to change our client side code. Once our client side code is ready and it is deployed on the client side, we don't need to touch it. Here factory acts like as an interface. Any changes in the object creation process, we will do appropriate changes in our factory. So this was the problem which factory design pattern solved. Now what if there are more than one factories? So to if there are more than one factories, then to solve this problem comes the abstract factory design pattern. So here I have will give you two examples. One will be the example in the automobile industry, and another example will be in our software engineering. So have a patience, stay with me, you will understand. Okay, so the abstract factory design pattern is a creational design pattern that provides an interface for creating families of related or dependent objects. Here the term families of related or dependent object is very important. So it falls under the category of creational design patterns which deal with the object creation mechanism. Abstract factory pattern is useful when you need to create a family of related objects such as type of products in product line. Okay. So to give you an example, let's suppose we see an example in automobile industry. Let's suppose as of now there is only one brand in the market, that is Tata Motors, and you want a car. So you don't have any other option. You just go to the Tata factory, ask for a car. So all the objects of that car, the tires, the car engine, car seats, doors, they form a family because they are interrelated with each other, right? You can't use a car A's engine in car B. So these objects are interrelated with each other. So whenever you ask an object car, what does the factory do? Factory does it accommodates all other small objects, assembles them into the factory, and then provides car whole as an object to the client. Okay, till now it's very clear. But now imagine what if there are more than one brands into the market. Now let's suppose there are two brands. One is Tata brand, another is Toyota brand, and the client wants the car. Now, what if the client chooses for the Tata car? He goes to the factory. Each time he has to specify that I want a Tata car. So I want a Tata car object. I want Tata engine. I want Tata tires. I want Tata seats. I want Tata doors. So all these Tata objects or family of the object, as you can see, will be assembled into the factory and the Tata car will be provided to the client. But now, as you see, each time the client needs to specify, right? He needs to choose from the list of the brand which brand he wishes to have, and corresponding to that brand, those family of the objects must be brought together, assembled, and the car must be given. So there is too much of the choosing process here for the client. The client needs to each time choose the part belongs to the Tata car or Toyota car, that what he wants between them. So I know this example is pretty vague, but stay with me. Another example which I am going to show you that is in related to our software engineering, so you will understand more. As of now, let's go ahead. So you understand the problem, right? So here in the abstract factory design pattern, here this pattern is useful when we have more than one factories. So it's particularly helpful in scenarios where you have multiple families of related objects and you want to switch between these families without changing the client code. And okay, so as I said, when you have multiple families or multiple factories. Why the term family here is used? Because all the objects, they are interrelated. They must be compatible with each other. And each time the client changes, like we are shifting from the Tata car to Toyota car, each time there are the changes happening. So to switch between these families without changing the client code, to make it very seamless experience for the client first demanded a Tata car and now he demands a Toyota car. So this change must be very seamless for him. To solve this comes the abstract factory design. Okay, so now let's see an example in the software engineering. So imagine that you are developing and creating GUI components. What does the GUI stands for? GUI stands for graphical user interface. So any type of buttons, text box, checkbox, animation you see on your operating system, they are briefly the part of the GUI system of that particular operating system. Each operating system has its own GUI components. For example, there are different kinds of operating system: Windows, Mac OS, Linux. Each operating system has its own set of GUI components that need to work together cohesively. Okay. So now let's suppose you are a front-end engineer and you are working on some application. Now each time you are working, you need a button in your application. So each time you need to specify that I am working on a Windows operating system, so provide me a Windows button. I am working on a Mac OS operating system, so provide me a Mac OS operating button. So because Windows button can't work on the Mac OS and vice versa, Mac button can't work on the Windows. So each time the front end engineer needs to specify that please provide me Windows button, please provide me Windows checkbox, Windows text box, etc. So this becomes very inconsistent to maintain in a very large code base. So as you can see here, without abstract factory, you would litter the code with conditional checks because each time there is a conditional check that button is been asked, but which operating system? Windows, Linux, OS. Okay, Windows is asked, so provide the Windows button. So there are lot of if statements to be checked, and there is a lot of lengthy process to be followed. So this would lead to code that is hard to maintain, less flexible, and error prone. An abstract factory pattern solves this problem by providing an abstract factory as an interface. So, like, I don't want this. What I want is that only one time I will specify that I am working on a Windows operating system. So, whenever I ask any of the GUI component, you always provide me that respective operating system's GUI component. I don't need to specify each time. At start, I will say I am working on Windows button. Okay, I will say just give me the button. The Windows button will be given. Just give me the text box. The Windows text box will be given. Each time I will not specify. To give another example of this, let's suppose you are downloading a software from the net. And each time you download the software, only first time it asks that on for which operating system the software is been asked for Windows, for Mac, for Linux. But you download the software. Now, for the subsequent updates of that software, you don't specify the operating system. The factory itself understands that the update is for the Windows, the update is for Mac, or the update is for Linux. So only at the time of download, you say that I am working on Windows, so give me the Windows software package. Software package is been installed on your machine, working everything fine. Update comes, you just update. You don't specify the operating system you are working at. The process itself figures out that yes, this is a Windows client, so give him the Windows updates. So this pattern is this problem, like how is this solved? This is solved by implementation of abstract factory design. So as you can see, this is a pictorial representation. As you can see here, we have just one more layer of abstraction created. To go back in factories and pattern, we have three layers: client layer, factory layer, and the object creation process. Now here we have one more, that is abstract factory. So the client layer, abstract factory, which does this job of figuring out the client is Windows client, the client is Mac OS client or Linux client. This layer does that job. Then appropriate factory has been called, and the appropriate, like whatever the client demands. If the client is demanding button, then providing button. If the client is demanding text box, then providing the text box. So this is what happens. So the client first talks to the abstract factory. At first, it mentions that I'm a Windows client. Okay, abstract factory remembers that Windows factory is created. Then Windows factory provides the appropriate objects as the client demands. Same thing happens in the Mac factory. Okay, so now let's understand it via code. So here I will explain everything line by line. First, go to the int main. So what happens here is that first we enter our machine OS, which we are working on only one time. Here we get our OS type, and then as you can see here, here we create the factory corresponding to that OS type. I will explain each and every function, each and every class. Just have patience. So that kind of factory is created here. So if the OS type was Windows, we get here Windows factory. If the OS type was Linux, we get here Linux factory. Then we create here button. So I just specify that give me button. See, factory create button. I'm not specifying the OS type now. I just say give me the button. The factory is Windows factory. Factory itself understands that, and factory by default provides me the Windows button. Similarly, the text box, factory just says create, give me the text box. That is, client is just asking for the text box. He is not specifying the OS type. Factory itself understand that I am a Windows factory, so I must give him the Windows text box. And how is this decided? This is decided at the start, as I said. Accordingly, what OS type you enter, appropriately that factory has been created. Okay. So now let's start from the start. So here I have my interface button. So I stands for interface, I button. Here it is an interface. Here we have pure virtual function. Here virtual void press equal to 0. Here this is just to like mimic what the actual button does. So button job of button is to be pressed. So virtual press equal to 0. Similarly, now the Mac button will inherit this interface, and here I have the concrete implementation of press button. It will say Mac button is pressed. Similarly, Windows button, it will be derived from the I button, and here I have concrete implementation of press function where it says Windows button is been pressed. Similarly, here I have interface for text box where I have pure virtual function, virtual void show text equal to 0. Then I have my Mac text box and Windows text box. Both of them are being derived from this interface which I talked about, and both of them have their respective concrete implementation of show text where they say showing Mac text box, showing Windows text box. Okay, going ahead. Here I have my interface for the factory, which has this two virtual functions, create button and create text box. Here it provides the interface for the button in the return type and text box in the return type respectively. Next, I have my Mac factory and Windows factory. Both of them are being derived from the factory interface. And here, which I have this virtual functions, right? Here I have the concrete implementation. As you can see, the Mac factory creates the Mac button, returns that, creates the Mac text box and returns it. Similarly, Windows factory creates the Windows text box, returns that. Here this is my abstract factory. This client only talks to the abstract factory. Client doesn't talks to the Windows factory or Mac factory. So here I have my static functions. Static functions are those functions which belong to the class. Here create factory. So here the at start initially the client says that which factory do you want? Are you a Windows client? Are you a Mac OS client? Or are you a Linux client? So it takes the OS type as an argument. If the OS type is Mac, MAC, give him the create the Mac factory, return it. If the OS type is Windows, then create the Windows factory and return it. Else, if client enters anything rubbish, you just say enter a valid factory type, return none. Okay. So as I said, here the OS type is been entered. The abstract factory, we talk with the abstract factory. According to the OS type that the client entered, that particular factory is returned here, whether it is Windows or Mac or Linux. Then the button, the factory create button process is called. We press that button. So we will see the message that if the Windows button was pressed or the Mac button was pressed. Similarly, text box, we show text from the text box. If it is a Windows text box, show it from Windows. If it is a Mac, show it from the Mac. Okay, so now let's run this. So it says enter your machine OS. I will say Windows WIN, and then I get Windows button press showing Windows text box. Similarly, I run it again, and this time I say Mac. I get Mac button press and Mac text box. Okay, so this is how the abstract factory works. And this is the real life example of how the abstract factored pattern is implemented. And this is its pictorial representation. I hope you understand. So stay tuned for the latest update. In the next video, we will be discovering yet another creational design pattern. So if you have any guesses, do mention them into the comments. And if there are any feedback for the videos, also let me know the feedbacks. I am open for that. So that's all from my side. Thank you for watching.